I can take advantage of several different kinds of visualization modes that we have. In addition to tabular mode, we also have a force graph mode. And force graph mode is particularly helpful as a way to see how nodes are or are not connected within the graph. As an example, let's lift all of the nodes that are tagged with fireeye 2020-12-13. So everything that came in through the blog and through the GitHub CSVs. And when we lift these, what jumps out at me is that there's several clusters of nodes where we can see that the nodes are connected. There's also a lot of nodes that are just kind of floating out by themselves, like this registry key and this file base that are not connected to anything. If we remember what this looks like and we go and lift a different query, if we lift everything that we've tagged with VTX story.nightwatch, this includes data that we brought in through enrichment and pivoting that we determined to be relevant to this set of activity. If we go and we lift this, the visual is different. We were able to, through that additional enrichment and research, we were able to connect all that information and be able to uncover a lot of the evidence supporting FireEye's assessment that this was all the same set of activity. It's all cohesive, it's all related to each other. We were able to identify all that and reflect it within our graph. Force graph is a helpful way to be able to see those connections that would be more difficult if we were in, say, tabular mode. If I wanted to have a statistical breakdown of a certain set of data, I can always use stats mode. For this, we'll take a look at all of the file bytes nodes that we have within this cortex that FireEye has reported as associated with APT1, and we're specifically interested in those that have compile time data. Now, stats mode will take the results of this query and display it in different statistical projections for me. One of them that is particularly interesting is this over here, where I can see the breakdown by days of the week. It shows that it looks like the vast majority of these file bytes nodes were compiled Monday through Friday. There's a little bit of activity on the weekends, but not nearly as much. This might suggest that this was more of a organized, concerted effort rather than someone just compiling malware as a hobby in whatever free time that they had. I can always take this breakdown and change it from days of the week to see hours of the day. And the peaks and valleys here might give some suggestion of when people are breaking for lunch or for dinner. The times where there's less activity might align with the time that someone is sleeping. So what I could do is I could always take what we had seen from the breakdown over days of the week and what we see from this breakdown over hours of the day and try to identify a time zone in the world where this would align with more of a 9 to 5 regular workday schedule. And that might be some additional evidence supporting my assessments of where these operators or these developers may have been based. I can also take a look at the compile times broken down over a longer time frame. For example, this is broken down by week, but I can go and change it to month, or I can also go and change it to the breakdown by year. It looks like we have one bytes node that at least has a compile time of 2004. The vast majority of the samples that we have compile times from 2009 through 2012. Looks like we have 2013 compile times, and then that's the end of the data that we have for this data set. So stats mode can be a helpful way to break down your results into these different statistical projections.